Welcome to Microprocessor Microcontroller course. Today we are going to discuss the addressing modes of 8086. The objective of this topic to understand the instructions which will be performed to access for the processor. That's the required for the objective of addressing the modes. Several instructions may address the same addressing modes. So, for performing a program in a microprocessor, we need the data instructions should be addressed with the any one of the addressing modes. Outcome. The outcome of this topic, after learning these addressing modes, we can easily use the instructions in several areas. Yes. Let us go to the topic. In 8086, we have 8 types of addressing modes. Then what is addressing mode? Each instruction requires the data to be addressed. So the methods we have to address the data is called addressing modes. Totally 8 types of addressing modes available in 8086 microprocessor. First, immediate addressing mode. Next, register addressing mode. Next, direct addressing mode. Fourth one, register indirect addressing mode. Next, base addressing mode, index addressing mode, base index addressing mode. And finally, base index with displacement addressing mode. Let us see one by one. First, immediate addressing mode. The immediate addressing mode in which the data operand is a part of the instruction itself, which is known as immediate addressing mode. Example, move CX, 4929H. Here, the data, which is the value of hexadecimal 4929, which is moved to the register of CX, which is nothing but combination of CL and CH. So, the data operand is the part of the instruction. So, in this instruction, the data part is the one of the part which will be directly given. So, this type of addressing mode is said to be an immediate addressing mode. Like we have another example, add AX, 23A7H, which is means 23A7H, which will be added with the AX register. So, in AX register, we have data. That data should be added with 23A7H. Finally, the added value will be stored in the AX register, which is nothing but combination of AL and AH. Next, move AL, FFH. Here we have AL data, FFH. So the data should be moved to the one part, it is AL. So the value should be stored in the AL register. So these are the examples for immediate addressing mode. Next, register addressing mode. Similarly, it means the register is source of an operand of an instruction. Register is source of an operand for an instruction. Example, move CX, AX. Previously, we see the data will be one of the instruction. Here, directly the register is the source. So, move CX, AX, which means the data which is available AL and AH is moved to the data to CL and CH. So, it will be copied from one register to another register. Here both are address mentioned in the instruction have registers. So, this type of addressing mode is said to be a register addressing mode. Next, add DX, AX. So the data in AX, the data in DX, both added and it will be stored in the DX register. Right. Next, direct addressing mode. Here, the addressing mode in which the effective address of the memory location, is written directly in the instruction, which means the effective address. We know segment address, we know offset address. Then what is the effective address? Effective address is nothing but combination of segment address into 10H plus offset address, which is nothing but an effective address. Right. Here, example, move AX, 1592H. Here, the location 1592, the address of the location, the data will be moved to the AX register. So the data which is present in the address location 1592H will be moved to the AX register. Please note it down. The first line, you will observe that only the values will be given. Here, that address will be mentioned within a bracket. Within a bracket represents address. Without the bracket represents data. Please keep in mind that. Similarly, move AL, 0300H. These are the examples for direct addressing moves. Next, register direct addressing mode. These addressing modes allows data to be addressed at any memory location through an offset address. Through an offset address held in any of the following registers. I will repeat. These addressing modes allows the data to be addressed at any of the memory location through the offset address, which is held in any of the following registers like base pointer, base registers, destination index, and source index. Let us take an example. Move AX, BX. So the BX is nothing but BX address content will be moved to the AX. Similarly, add CX, BX. So the address of the BX register should be added with the CX register and stored in the CX. Right? So this is register indirect addressing mode. So the address at memory location through one offset address. Next, base addressing mode. Here, the addressing mode, the offset address of the operand is given by sum of the contents of BX or BP register and 8 or 16-bit display. Let us see, move BX, BX plus 04, which means the address of BX plus 4 displacement. For example, take 1, 2, 3, 4H plus 04. If we add together, we may get one offset address. That address should be data present. So the address of the data should be moved to the BX register, which means the operands, which is nothing but sum of contents of BX or BP register with a displacement of 8 or 16 bit. So here BX plus 4. Similarly, we have another register add CL, BX plus 08. Similarly, the address of the BX register plus 8 displacement, that address can be moved to the or add to the serial register. So these are the examples for base addressing mode. Next, index addressing mode. As name itself, in this addressing mode, the operand's offset address is founded in adding with the contents of source index or destination index. That's why in this addressing mode is nothing but index addressing mode, which is with the 8 or 16-bit displacement. Previously we see, right, base register. Here we just mentioned only the index register. So we have two index, source index or destination index. Let us see an example. Move BX, SI plus 16, which is nothing but the address of the source index plus 16, which is nothing but adding together and we may get an offset address. That address of the data should be moved to the BX register. Next, add DA plus 16. Similarly, we have a destination index. The destination index address plus displacement of 16. We may get an F2 address. That address of the data should be added with the AL register and it should be stored in AL content. So these are the examples for the indexed addressing mode. The next addressing mode, base index addressing mode. Previously we discussed base addressing mode, index addressing mode, which is the combination of both. This is nothing but offset address of the operand is computed by summing the base register to the contents of the index register. Previously we just taken a base register at the displacement. index register and displacement. Here, the summation of base register to the contents of the index register. Let us see an example. Add Cx, AX plus Si, which means the address of AX register plus the address of source index. Both summing together, we will get a new address, which is nothing but another address. That address of the data should be added with the Cx register. Similarly, move AX plus Di. We have AX register, the address of the AX register and address of the destination index register. Both added. The added value should be moved to the AX register. So these are the examples for base index addressing mode. The last addressing mode is base index with displacement mode, which is nothing but base addressing mode, index addressing mode, base index addressing mode. Here we have added base register, we have index register added with the displacement. Let us see. The operands of offset is computed by summing or adding the base register contents and index register contents and 8 or 16-bit displacement. The contents of base registers, the content of index registers with displacement 8-bit or 16-bit displacement. That's why it may be called as base index with displacement. Let us see an example. Move AX, BX is the base register, DA is the index register plus the displacement 08, which means the address of BX register plus the address of destination index and added with the displacement with 8. After adding, we get one address which should be added to the displacement of 8 and the content of data should be moved to a AX register. Where another example, add Cx, BX plus Si plus 16. Base register plus index register plus 16. This address of the data should be added with the Cx and stored in the Cx register. So, these 8 addressing modes give an idea how to fetch the data to the instructions. Now you can easily categorize from some instructions may come in under a repeated of several addressing modes. So, hope you may get some idea about the addressing modes. In the next video, we may discuss instruction sets. Thank you all.